Alpha Houston on space to ground 1 for Don. We're ready for your downlink.
Okay, I'm going to hit play.
I'm Don Pettit. I was fortunate enough to be science officer on Expedition 6 to the International Space Station. And during this expedition, we had several kinds of science that we did. We did programmatic science, which is well-planned and well-thought-out science, comes up from the ground and is orchestrated from the ground. And then we have science of opportunity. And this is science that is done at the discretion of the scientists on board space station. And this is kind of the discovery science. And during our mission, we called our science of opportunity Saturday morning science. So we've seen how you can make these films of water held in place with a wire loop. Now we're going to look at some of the things you can use these films for other scientific investigation. And since you have this sheet of water, fluid motion is basically eliminated perpendicular to the sheet. So it allows you to investigate motions and processes that occur within the plane of the sheet. So you basically have a two-dimensional problem that you can observe where motion in one direction has been eliminated. And we can observe the effects of forced convection and then the effects of diffusion. And so here we're going to look at some diffusion properties that the weightless environment of space station allows you to observe. And we have one of our standard 300 micron thick films that's 50 millimeters in diameter. We're putting drops of food coloring on the film. And notice that the food coloring just sits there. There's not any convection which is causing this thing to get stirred around unless you puff on it. And here we're puffing on it with a syringe with a little fine cannula tip. And while we puff on the film, you get fluid motion. But as soon as you quit puffing, the fluid motion stops.
So you can see how just the slightest amount of force from the air will make the water move. And if the water has pigment in it, why then the pigment will move, as you're seeing there.
And you can end up making these delightful colored structures that almost look like some form of a Matisse painting done in water and food coloring in the weightless environment on space station.
It makes us wonder what someone like Matisse could do with a medium like this. And this is Sox is doing the work with the cannula there, blowing the food coloring around.
And look at that. This looks like we have a little dragon puffing out green smoke. And here we're showing a little cutaway that illustrates what the wet chemistry lab looked like. It's in the FGB module. It's in our shower area where we take our showers, and we turned it into a wet chemistry lab. And you can see for a background, we have one of our cleanest dirty towels, makes a nice white background. And then here we're panning down to show an edge-on view of this film, and you can see indeed it is very thin. When we pan back up and look at our little dragon, and what we're going to see now is the effects of diffusion over a period of about 30 to 40 minutes. Here we are, 30, 40 minutes later, and look at the edges of our dragon. Look at the edges of the color. You can see that they're all diffuse and fuzzy. And this is the effect of diffusion. Diffusion is slow in a water-type system. It takes 30 minutes to an hour to show changes where it just slowly makes the edges fuzzy. But now watch what happens when we puff on this. We put a little puff of air, and you can see the edges sharpen up. As you're driving new convection, we incite fluid motion, and it makes nice sharp edges again. And here we are. We're changing our dragon into more of an abstract art form as we do more puffing on it. And you can see that the puffs of air will incite fluid motion, but as soon as the puffs of air are removed, the fluid motion stops, and then you can watch diffusion set in again. And you see right there, I bumped the frame. It made the water film oscillate a bit, but it still preserved its continuity.
And here's what happens after we've stirred all the film up, and we get this kind of yucky green color. And I think this is conclusive proof that here on the space station we've discovered what the true color of the universe is, and this is it.
And what we're going to see now is the effects of diffusion over a period of about 30 to 40 minutes. We put a little puff of air, and you can see the edges sharpen up as you're driving new convection.
And Houston Alpha, that's it for our Saturday morning science.